All right, I'm back. So part 2 here, just to kind of finish up this little rough draft of a program that got going. Let's see, where were we? So we've got generate world, makes our people, puts them on the map. And then we'll just run it real quick just to show it. So if we change map size, then it scales it. So now what we need to do is when we selected this, we need to display what the genome is, which genes are involved. We need to map the brain and put it into a display. So let's do that. So in our main form here, on select box 5, selected index changed. It's basically any time that this box is selected and it gets changed, we're going to do something with it. So we're going to basically take the citizen name, spots 5 dot selected index selected item. Select the index. We've got a name and then what the number is represented in this list box. So now we need to get the genome. And now that we have the citizen index, basically we can go against the population array of what's created, and we can figure out what the length is based off of what the citizen data has in it, because it's got the length in here, and then it's also got the actual genome that's associated with the citizen, and then we're going to grab the brain that's associated with the citizen. And then we're going to grab the genome of the brain so that we can match it, just to make sure. And I believe it's, let's see, which list box do we want here? List box 3. So we want to clear out the items in list box 3. So if citizen genome equal the brain, then we can catch it and we can do something with it. Now, a lot of these things I haven't really gone through all of the stuff as far as going through and making it all proper. You know, a lot of this stuff is just to get it working. So there is some stuff that might be missing. Now, this is the other thing you could do with a with a list box is you can kind of create your own little console, and then you can create like an identifier for this list box. So you can say list box main box, or like log box or something, and then you could say list box 3. And then you can use logbox, if you put this up at the top, all the way up here. If you're going to use something a lot, you could put it all the way up here, and then you could just use logbox dot whatever, logbox dot add, It does that. What is that? Oh, because I didn't. Never mind. But anyway, you can kind of you can shorten some of these, because some of these get kind of long. I'll show you in the brain, especially. Some of them that I've made are kind of long, and some of them I've shortened, and some of them I haven't. But you can simplify this so you don't keep typing listbox 3.items. All right, so we're getting the owner of the brain. We're going to get the see, where am I putting that? Yeah. We'll do this for the owner label. We'll put this dude in here. Like this one is going to be a long one, so I'll just copy it. But basically what we're saying, this is going to show us how many genes and all of that in one of those labels. So right now we're basically just populating all of the text labels for stuff. All right, I'm going to copy this in too because it's easier, and then I've got to figure out where my 15, 16. Do a name. 15, 24. Is it about the same in it? 31 and 26. The world state get coordinate. We had that. Oh no, we never added it, did we? Yeah, so this one is basically state. So we'll create a new coordinate of just blank. And I is less than. So we have the world coordinates of I dot x equals the x that we sent and the y equals the y. Then we're going to take this chord equals then we return it. All right, so there we are. So we're going to get the occupants of that coordinate. And turn it into a citizen list here. And then this I don't really want right now. And then the occupants list, we're setting a new event handler for that one. And then we're going through all the males and the females. Okay. And then we add that in. I think that populates most of our stuff. Oh, I've got to do... We've got to add the link list in the brain, and then we've also got to do the draw for the brain. So we'll just finish up these little... So basically this is what this is going to be, the link list in the brain that goes into that long list box. And then we're going to clear out the I forget which list box. I forget which this one is, but I think it's the input. It shows the inputs. And then the picture box for the brain we want. Come on, man. Doesn't want to work. There we go. What happened there? Let me try it again. Kind of memory something or other. That's not the one I want. There we go. Picture box 2. So this is where we're going to draw the brain. Picture box 2 image. We've got to write show brain and get gene and draw pixels. This is world. So let's go to the genome and finish off that get gene. Let's return in so I'm going to return a gene and try to return the genes into genome of X. And catch it. So we'll return that one, and if not, then we'll just return the first one. Okay, there's that. And then what else do we need? Brain map and and then in the gene we need get gene name. Gene. Okay, so that puts the gene in the first list box. Let's make sure. One in list box 4. So show brain in brain. Create X and height. And this one's going to be kind of a long one. Wait, is this a bitmap? This might be a bitmap we're returning. All right, so we're going to return the map, or basically a bitmap of the brain structure. And bitmap is system drawing. So import that. So source neurons. Oh, wait, no, I just want the array. Yeah. So we got the width, the height. All right, so oops, I spelled that wrong, didn't I? So now we're going to use graphics to start drawing crap. Not crap, but so we'll go from so basically it takes the size of this bitmap and information, starts a new graphics. And I've drawn I've made another function for each of the neurons just to kind of simplify it. And we're going to return what we drew on and then dispose of the graphics. Yeah, draw neurons is a big, long, but we can go over it. I'll just copy it though, since it's a lot of typing. All right, so here it is basically. Let me spell this right. There we go. Okay. So I'm dividing out the width basically into small groups to make these, to decide the size of the neurons that we're going to draw, basically. And then I've got a different color for all the different neurons, what their different connections are. The lines I haven't done yet, but the lines would have the line weights associated. So I'm basically redrawing what he was using, a library that's out there. I'm just kind of doing it like I kind of wanted to see how to do it just on my own on the C+ side, because I can do it on like PHP and other things. I just have never really messed with it on this front. So basically, yeah, we've got a bunch of brushes that we're creating so that we can draw onto our graphics that we sent in. And we've got a list of we sent in the brain. And the reason we sent in the brain is because the brain has all of the information that gets when the neurons are created and they create the behavior. The behavior sends that information back to the brain. So the brain should have all of the information with the behaviors and everything at this point when we draw it. So that's why a lot of that was like the tuple list being sent all the way back down to the behaviors and then being all the way sent back. That's kind of the purpose of it, is to be able to draw it. So I'm going to wait too much. And then we're just basically adding it to these different lists that we're making of strings that will be drawn onto the ellipses, which are basically circles. And then you'll see how it goes on there. But like this is of like all of the inputs here. We're going to go through and we're going to find the first, we're going to find the key of the input in the brain. And then we're going to look for the behavior key of the source neuron list that it got from the behaviors and see if it matches. And if it matches, then it's going to fill the ellipse with the selected brush. And then if it's not within that, if it's not within that array that we just created earlier, then it'll basically determine which brush to use and whether to highlight the neuron or not with the brush. But it'll make more sense when I do it, but we can go over it if... I'll just kind of do it here so that people can kind of look through it when they get back at it, and they can kind of look over just at least some of the logic. There's a bunch of different ways you can do this kind of stuff, but I'm basically adding all of the locations to the source image, the brain image locations, and this is basically to be used for the lines, so that when the lines are going to be drawn later, they know where the neurons are. So it's basically mapping the map of the neurons that we just drew is what that's adding in there. And then we draw the string on top of the neurons once we're done, depending on whether they're used or not. And then we dispose of all the brushes and dispose of the... Did we dispose of the G? Yeah, we dispose of the G up here. All right. So that should draw our brain. And now for the... What are we doing here? So this is determining... Since we're in this list box selected item changed, this is going to determine change pixel of selected citizen is what that's doing. So it's changing the pixel of whatever citizen is selected within this list box. But we have to do that on the world state. Copy that one over too. If I can find it. There we go. Alright, so when we get the world state, we'll add this. So we're returning a bitmap, and we're drawing pixels. We give it the location of the citizen, basically, and we're giving it the color, and then we're giving it what world it's on. So it's going to go through all the coordinates of the world, and then it's going to, when it finds the coordinates that are X and Y, it's going to change the color of the, it's going to change the color of the pixel. I don't know why that's there. Oh, this might actually... I forget what this is. Sometimes it's one line like this. It makes the whole difference. I think this is the one that tracks for the history. Yeah, before it saves it. I think that's what this is doing. But we can double check it by taking it out later. So we need to do the change color. All right, so when we're changing the color, we're bringing in the X and the Y, the color, and the map that we want to change. So if nothing changed, then we put the pixel in, because we have our default value set at -1 in the world state. So if it's default, then it puts in the base color here. But if it's within the range of the map, it will put in the default color. So that's basically what it's saying here. So you can put in whatever color, and it's saying that if it's the base map, the very first beginning map, then it's going to highlight your pixel. So let's see if that works, because I think that should be all we need to fill that in. Let's see. I don't have build errors. Oh yeah, what was I doing for that? Did I just not forget? Oh, is that where it crashed? It must have been where it crashed and didn't remember what I put in there. All right. That we don't want, because I was just doing that as an example. And that we decided to cancel out. All right, so we've got a green dude. That's our selected guy. So every time we select one, we've got a different one that's selected. We've got our genome members. So we've got 2 genes in the brain. We've got 1 occupant in this area. We haven't done any of the run generation stuff. So if we do higher genome, like 7 genomes, and there's something it's not liking. It's not as quick as the, I'm not sure why it's doing that. Yeah, so now we've got a bunch of genomes, but it's not drawing the, let's go back to the draw. Action. What am I forgetting here? All that stuff. Graphics from image. Might be missing. Oh wow, it didn't finish up. It's weird. I guess when it crashed, it didn't. But like half the stuff that I had written or copied anyway. Oh yeah, we need to make the, all right, so we've got a genome match. We're gonna make the link list in the brain. Wait a minute, we are doing that. Oh, did I not? I might not have added it in when I did this. Wait, list box item 3. I don't think I want that. 2. Where'd it go? Guess I didn't add it in. Xbox 2. So that'll add the list box, I believe. There we go. So we've got our from an inner source gene. We've got our source type. It's an inner source. It's got a weight of 0.378 and it's got a positive sign. So that's this gene. So it goes from a source inner to an action. And then the next neuron goes from an inner to an action as well. And then we don't know which one it's going to just yet for because it's got a default action. Because we need to add in all the behaviors is what we need to do. So we need to make basically, I haven't really figured out, I want to do this from the file, but I haven't figured out how I wanted to do it yet. But here's the big long list of behaviors and strings associated. So these are the keys. So this is the key. This is the action. And then this would be the function associated with it. So that's kind of why I haven't done too much on that. And then I have it set up to basic. So let's see if that does what we're supposed to do, because this might actually do everything that we need. Oh, and then I need my alpha array just for shits and giggles. All right, so I got a little alpha array there of capitals, and it's basically under the basic, which is how I designed it. I've only got like 3 actions which really don't do anything at all, and then I've got all the basic movements like move east, west, north, and south, and then the weights all determine the chance whether or not they move. So it's kind of the same as what that other guy has, but it's just not. This is all of his list of stuff, which I haven't done any coding for yet at all. And then this is kind of what mine was that I designed it with. And you can kind of see at least how you can get it to start doing behaviors, you know? And then we can kind of add some behaviors. Yeah, there we go. So we need to make the dictionary when we... So basically this is loading all the behaviors so that it can send it all the way down the line as everything's created to the behavior class, so that it can determine which of those behaviors to use and then send all of the chosen behaviors back on up the line. Basically is what we're accomplishing with that. So we need to, when we start the form, we need to make dictionary for input. And then we'll do it for action. Oh wait, we need source, not input. Good thing I double checked that. So we need source, okay. So let's see now if it populates all the stuff that we need, which is why, that might be why we have a delay there. I'm going to have to try it. I'm going to have to do a... And then we'll just do... for adding the inputs. got those. I'll try it. Let's see what happens. What happened there? I wonder if I... I'm going with that. Stop that. I'll just do this. If it wants to catch up. Alright, fine, we won't do anything with it. Alright, let's see if what we were doing. Something is up with my... They determine... Maybe that's what we did. Nope, it's all there. Let's look at this again. So we've got the people, and they've each got stuff, but they don't have their default ID, which is in citizen. Oh, did I use the... Maybe I'm using the wrong... I think I'm using the wrong... Let's close this up. So we're using basics, so I don't need to worry about this crap. And I don't need to worry about that crap. Let's put 6 inputs. just gonna. Oh, I know. Ah, that's right. I haven't even done that code yet, so I'm gonna just cut this out. It should load. Oh wait, what did I do? We didn't load our. I didn't load them. We need to load up the tuples. That wasn't actually loading the tuples. That's what we have going on there. It doesn't know what it's looking for. So we have a make dictionary, and then we have this load tuples, which is going to load up some of the oops. I forget now. Back up the map. We've got what's part of that is not me. So we'll do this real quick. Let's look at list box. Or not list box. Brush. Set. Now I'm just going to copy these. Whatever. It's not liking doing that. So I'll just do this. Maybe I won't. I just want to add like 3 labels. There we go. Alright, so list box 8 we got. Picture box 1. Still didn't add our behaviors in. So we got people with some brains, so we got to fix our brain map and our behaviors. So let's go back to the brain map real quick, figure out what we did there. So it's adding the inner neurons. Do we have number sensory inputs? Plus P. When we create the gray brain, we're creating those. But he's saying he doesn't have anything. He's sending those. But he's saying he doesn't have anything. We'll create these. You know, sometimes it just helps to do shit right. There we go. So we got behaviors. One capital B away from everything. All right, so here's our behaviors. This is the basic one that I did. So we've got some basic inputs which aren't doing anything. And then we've got some movement that basically, if the weights of the world. And now we've got the brain drawing the map. So as you can see, for every little guy that we create, what we've got now is we've got like a similar structure. The only thing different from the guy's video and what we've got here is the lines aren't being drawn with the weights associated to them. But you can see them down here. So basically this would be this gene here, and it's coming from the CI action, and it's going to the AO gene. And oh, what the hell did I do with? There was somewhere where I had it where I was mapping it into the list box. And it might be trying to this box. Let me see if it's box 3. Editing the gene link. Link list. Total occupants. And there's one more thing we need to add. All right. So in list box 3, there we go. All right. So yeah, this little box now maps it right. So you can see that it's the DO gene is moved south, the CI gene is C neighbor, the EO gene is eat. So it's basically assigned these randomly, and like what the guy has in the video, some of them will be able to move, some of them won't be able to move. Like this guy's got move south and move west, so he has a good chance to move. He's not always going to move south and move west the way that I've got it set up. But if he's going to move, that's where he's going to move, just because the way that his brain is designed here. Now, if we wanted to make a more complex brain, then we've got, you know, much more connections to where this guy's got much more of an option to move north. He's got more connections that could weigh into this inner neuron. Like if we're only using one inner neuron, but we could use 3 inner neurons, for example. And depending on how those are modifying the inputs, could modify either the rate of movement or the chance of movement, however it works. So that's kind of how these inner neurons are going to affect they kind of affect the weights and the way that it feeds back on itself, if you design it that way. But it's kind of a neat, the thing that he's designed. Has really been fascinating to do it. So we've basically got to where we've got, I don't even know if I got that working. No, I didn't get that working yet. And we don't have our world history yet. So there's a couple things we have to add in, which is we've got our behaviors. Now, if I cancel this out and I do, for example, which I haven't set, I didn't get to the point yet before I started thinking, well, maybe I should do this tutorial for people who might want to figure out how to do it like on their own. But if I set that to advanced, then basically we've got all of his inputs, and as you can see, he's got a lot of inputs. He's got a lot of possibilities here. So once all that logic is in there, then it'll be a more interesting, it'll be a more interesting result for sure, just based off of the different brain options. So that's basically, in a nutshell, it's basically we've self-drawn this little brain map. Of course, I should have it stretched out more and things of that nature, but those were the size of the neurons that I was dealing with, because I was only dealing with 3 or 4 when I designed it. But yeah, now all that we've got to run is for running each generation. So then as we do each generation, we'll add to the world history. And then the world history will have a set of maps here that we can pick up, like what generation, and then see what the map looked like at that generation. So we'll do that at the next one. And then we'll probably start going into how we might want to think about doing the logic on some of these, like how the pheromones should be emitted, like, you know, how we might want to program for that. So that'll be kind of fun if we do that. And I don't know when I'll get to this, but I mostly wanted to get this because now you've got basically the shell of something that works, to where these genes all have purpose, they all have weight, they all kind of dictate their own behavior. And once we get the thing to run, basically this guy will run depending on, like on the other one that I have set up, he'll just run randomly depending on how his brain is. And then once they're all run out of the map, then it's done. And then the next part would be to generate the children based off of the survivors. And then you would have the same model as this guy had. And then, like I said, you can add a lot more to it, like for Citizen, it doesn't have to be the simple creature that he's got in the video. I've kind of got my own idea of like some things that I might want to add into it, like, radiation squares, things that might add to the mutation chances of the genes, and just to kind of see what kind of crazy shit would happen in the world. I still don't have like the gradient for the genetic diversity. So that code would somehow have to be where it grabs everybody's genetic mapping and then somehow compares it into a list and then gives that list a set of like a color gradient. And then that's how instead of all the pixels being red, we could have multicolored pixels like he has in there. So that's how that would be done. But otherwise it should work by and large on the same principles that he had set up. Maybe not as complex because it's only movement. But it's just the logic at this point. Like if you added in whatever these little, if you add the logic in, and then from here, the idea was to add maybe the functions of each logic from the program itself, so you could just kind of play with it and be like, oh, okay, I want to add a function of, and I had some functions that I didn't add in to where it'll automatically increment the next one, like if it's DO is the max, and the next one it'll say EO on the key, and then that way you kind of know, and then you can add in a function as you're going to say like what happens if I add in like a flight gene or something like that, and then you could make it a whole new population with a whole new set of these behaviors that you can set at runtime, which was the idea, but it hasn't gotten that far yet. But you could see where you could do that. And then you can add in to where you just add in a bunch of behaviors, you create a bunch of people, you can create a list of people like with a program like this and put it into a world to where all of a sudden you're in a world like, where AI has learned how to avoid you or has learned how to go for the resources. Like maybe all the AI goes for the gold because you've trained it in this kind of a simulator, go for gold. So there's a lot of things you can do here, especially when you do the, like this is kind of like I have a food zone, a radiation zone, just kind of like a rough idea of when we set the overlays, like at the end of the generations, if they're in survival zone, then they procreate. But if they're in a radiation zone, their mutation rate goes up high. Or if they're in a food zone, then they're healthier, or something of that nature to where, there's a lot of variables that you can add into it. But it's a good shell that basically works for what it is. And then, we'll do the, we might as well just add in the, because it's actually not that hard to add in the generation stuff. So on run gen, we're just going to go to a new function called advanced gen. And then this way we can also call this a number of times in when we call it the year for however many steps we want to do at once. So basically this is we're adding the world state to the ID for the history, and then we go through it and we're going to step the generation in the world and do all of the world calculation stuff. And then this basically just updates all of the labels and things that we had for that. So now we need to do the step generation 1 in world state. And we need to update entity, actually. It's going to be an important one to do. So there's add entity, and here's update entity. So we got to do update coordinates, which is basically just going to take the X and the Y and put them in the occupant list, and then of the coordinate, and then take them out if we're removing them. So that's basically what that is going to do. So we'll do the update coordinate now. We'll just put it up below this. So we'll update coordinate, and it's basically, I had this doing all kinds of other stuff. So it's adding an occupant and then removing an occupant. Add the occupant and coordinate. Oh, that's because I'm sending the coordinate with it. Okay, there we go. So that's basically saying if we're adding it, we're going to add the occupant into the coordinate. If we're removing them, we're taking them out. This is update. Step generation 1, I think, is what we need next. So this is the function that basically is going to direct the behaviors. So if one of the behaviors is present on one of the citizens, then it's going to say, then it's going to do this citizen move on the citizen object. So that's the other function that we need to do. So once it's in the world says, okay, we're going to step 1 generation. So everybody that has move east, move east. Everybody that has move west, move west. Everybody has, and then that's what this function does. So once we go to everybody, which is each time there's a citizen, it goes through and says check and double check. And if it's in there, then do it. So we'll go back to the citizen and then we add that in. And so for citizen move, this is the only logic that I have so far on this. I don't need all that. All right. And so I've got this. So basically we've got the map that we're bringing in the world state. And the world state has all the information that we need. And then we're in the citizen now, so we're basically saying the direction that we want it to move. So it's looking through all the tuples and it's saying, okay, if there's a behavior within this citizen that says move west, and the weight hasn't been modified, which we need to do that. Get random int from double. And it's basically the same thing as we did from the get random from string or get random from int. The only thing is this is returning an int from a double. So the double is the percentage by how much. And then it'll give us a 50-50 chance of that. Or not a 50-50 chance, it'll give us a 60-40 chance or a whatever the percentage is on that. And then make child is basically where I've gone through to add the... I had it set up differently to where basically the logic on this goes through and says, so if it's move west, then basically update the entity on the map, remove it first, and then move the character. So basically, if it's saying if the location is greater than 0, which is not on the edge of the map, basically, since it's on the west, since it's not on the 0 is the west border. So if it's greater than 0, if it's still on the map, we're going to go ahead and remove them, and then we're going to go ahead and pull them back 1. And then if it's on the map, and then we're going to add it back to the map so that it knows, mostly for the occupant, so that it knows who's there. And then if it's allowing children, I have an option here that says allowing children or not. And I haven't really finished up this code, but if it allows children, then basically it's going to go through here and it's going to determine which are the occupants within the coordinate. Is there a male or a female if it's a male or a female? So if it's a male and there's a female, then try to make a child. And if there's a female and there's a male, then try to make a child. So they're just basically going to make a child whenever, they're just going to have sex whenever they see each other, is the idea. And so we got to do the make child, and it looks like we got to import the color. And so make child basically is we're taking the parent A and the parent B, and we're putting them into a function. And so the citizen child we're going to start off with is a null child because we don't even know if it's going to be made yet. But we're just kind of setting a placeholder here. So we've got the length of the genome of citizen A and B. And then we're going to compare those, and then we've got the genome of citizen A and B. And then we're going to create a child genome for the child that's based off of the child of the mother, or based off of the genome of the mother, who would be parent B. So we're sending in the male first and then the female second for the parents. And then we've got a double here that's basically taking the mutation chance of the parent, or which if it runs through radiation in its life, it might be modified. So if there's a high mutation chance on one parent and a low mutation chance on another, then that might affect some of the behavior there. And then the mutation rate of the child is going to be the mutation rate of the parent, of the father, is basically how I've got it set up. And then I modify that by taking both of them and then averaging it. So if one's got really high and one's got really low, the child's going to have an average. So there's a lot of ways you could do it, you know. But then we've got a name of the gene, and then for the length of the genome of the parent, of the first parent, add this in here. For the length of the parent genome, we're going to make a byte we're going to make a byte array again, and we're going to divide that genome by the 4. It's an 8-digit genome, so we divide it into two parts per, so it's 4 bytes. And then, so we've got the bytes of the parent A, and then we've got the bytes of the parent B. And the child gene is going to take half of the parent A, or it's going to take the 2 bytes of parent A, and then it's going to take 2 bytes of parent 4 or parent B, and then it's going to make them the child gene. So that's how that's going to make the child, basically. And then we have created child is true, where we basically set this child. The procreation is true. And let me see here. Did we put the children into the... I think that's what I was going to do at one point. Parent A, citizen children, add. So yeah, then we would add the... So here's where we would add the child, basically. And by doing that, we create a new citizen, and we're sending in the child's genome instead of having it create its own. So that's why we have to go back to create a new constructor for that. And then we're going to set the mutation chance on the child. We're going to set the genome, and we're going to mutate it based off of the chance. So we need to go to genome. Let's do that real quick and do the genome mutation. So we'll mutate the genome by doing... So we'll take the genome and the chance, and basically... Where's my random... There we go. So I've got 2 more little functions here that just basically get a random number from a number. And then the scrambled gene is what we're going to use to scramble the bytes. So basically we take we mutate it by taking in the genome and the chance. We get a random, and then we try to mutate it based off of that chance. If it's mutated, then it's going to scramble the gene in some weird way, which is that basically what he was saying, that it's going to replace one part of the whole structure, so that it would change the whole. It would change at least one input or output of the 4 that you've got. So that would be the mutation, how that works. And that's basically all it's doing, is taking a random, either a letter or a number. And then if it chooses a random number, then it'll put a number. If it chooses a random letter, then it'll put a random letter. And then that'll be mutated. So then it'll come back with a mutated gene. So that's kind of how I was thinking about mutations, is that it might be with mutations as they're born. He had it set up to where mutation was an actual parameter of the world. So it could be both ways that you could do it. So now we need to do the last part, which is this. The only thing difference on this that we're doing from what we created earlier is, if I can find it. Yeah, there we go. The only thing that we're doing different here, that what we did down here, is basically the same thing. The only thing we're throwing in is the inherited genes. So instead of saying citizen genome equals a new genome like we do down here, so we're basically saying make us a new genome when we start it. When we make the child, we're basically saying the new genome is what genes we just made or mutated or whatever happened to those genes. Now those are what we're going to use for this child. The brain is going to be it's going to be based off of the genome. So we make a new brain for the citizen. and then basically we added them to the world, and then all should be good for that. And I think the only thing I'm doing here is I need to where is that? World map and then genes. Yeah, genome. Oh, and then our tuples. Parent A. See, parent A dot genome dot which one do we have though? Oh, the brain is what we want. Brain dot input tuples. We're basically sending the same action and inputs that the parent had in the world. And there may be, this might be the time to introduce a chance for new actions to be, what would that be called? To evolve. So that would be the place to do that, would be when the child is born. Then you could say maybe there's a new chance that a whole new input list gets modified, and then you add a chance to move up because all of a sudden it learned how to fly, it grew wings, whatever, or it can move down because it learned how to swim. There's a lot of things you could do with that. And then we take the genome of the child and then we mutate it. So we're mutating it after the fact. And I suppose we can mutate it before the fact and send it in, because we're sending in a genome one way or the other, but we're sending in a parent genome. And then we add the child to the world to the population, and then we're adding that both parents had children and they're in their child list. Oops, what did I forget? Save state. Go with T in it. Alright, first of all, I need to set this back up to basic because I don't have any actual functions for the advanced list yet. And then we'll see if we've got like a So they're moving, but we aren't showing the movement on the map. In world history, we have a world state. So, okay, we've got a world history going in here. So we need to add the select the thing that's changed on that. We'll do this one. It's for brushes. We've got this box. Yeah. So now we're at list box 7. Selected in this change, we're basically going to take the image that's selected and put it into this picture box world history. I don't know why I named it that. So it's going to take the name of that, and then it's going to get the index of the list box, and then it's going to go through the world history at the index, wherever that index is. It's going to grab that image, and then it's going to go put it in the box. So that should do that. And then the world state. Step generation. The age. And we're moving. Now we're going to the save state. Now go to citizen move. Map to update entity. Just going back to make sure why we're not. Set coordinate color. Current position. Okay, so we update the entity, we set the color. Remove the step. I'm just trying to go through with the advanced gen maybe. Well, let's see what the world history shows us. It might show us in which way it's doing that. So we'll generate. All right, so here's our little world. It's not moving. But let me see if the world history is showing anything. Nope. What did I do there? Did I not just do? Interesting. We're not updating our map, but let's see if we got a world history. All right, so we're moving. So as you can see, all the green are all the guys that are moving, and all the red are the guys that aren't moving. So they only move for a little bit and then they kind of die off. It's kind of just how the program runs for now. But as you can see, you know, it works. It's got those neurons are doing random bits, and eventually, as you could see, even with these basic movements, even without even really action inputs. I'm not sure. I mean, I have to try it out some more on if it would have the same effect, but it almost might have the same effect just on the chance of that if they happen to move into the one region, then they'll live and they'll procreate, and they'll all, by numbers, have genes that will propel them to move in that direction always. So I think that it would still be the same effect even with no input programming at all, because these have there's nothing to dictate what happens when these neurons fire. It's giving weights, you know, it's dictating part of the weight. You know, some of whatever this number is getting modified by this number, and if this number modifies these numbers, then that's having some kind of an effect on each creature. But there's no actual programming behind it. It's just saying it's coming from a place where something is happening, and it's coming to this neuron where it's going to take its positive or negative charge, and it's going to amplify or make it worse. And then it's basically going to send that same data to the next action neuron and say, based off of the information I got from the other neurons involved, this is how often you should move and at what rate, is basically what's going on there. And that's the whole idea of what his little program was. So it's been really fascinating to try to go through all this and try to figure out how to map like these different behaviors to different, you know, from binary into how do you give it all a generic, you know, kind of a random brain map that yet has kind of similar function in form, you know? And so it's a really neat, I don't know, I really enjoy it. And so you can see from here, you know, I think my biggest problem right now is I've got the occupant list I need to fix. Because it's not listing them properly. It's putting both citizens, and I'm not sure where it's doing it at, but the occupant list is a little off. But once that's correct, then the spawning should work, because now it doesn't matter what you go into. It'll always be 2 males or 2 females or 1 male or 1 female. So there will be no procreation until I get that fixed on the occupant list. And then once I get that fixed, then we should be able to have like a natural procreation, or with the overlays, we can go into well, that's not the right. Maybe that's what's happening. I'll bet that's what's happening. Let me see if that's what's happening. So we got, this is picture box 1, and worldview is world picture box. So when we update citizen, no, update entity, I'm gonna go to the world picture box. Or no, when we step generation, right? Safe state. So the world map. So when we hit the button for our generation, we're going to advance our generation, and we're going to add the world map. Yeah, there it is. That's what it's doing. It's sending to the sending us to the overlay box, and we don't want it to go there. Here we go. You can see all the little dudes moving. Some of them. Doesn't do anything. But see, now we've got the world history. And I've got a highlight in green for everybody that moved in that particular instance, just to kind of see stuff happen, you know. And then the world view now will update as we run it. And then as the map is bigger and you've got more more neurons and genes involved, you've got a lot more of them end up starting moving, you know. So it's kind of interesting how that happens. But they all do stop moving at some point, for the most part. Once they reach their end, there's only a couple that kind of keep moving. But this guy down here, whatever he is or she is down there, is probably doing, you know, like this. It's probably just going to keep running for. Now he has okay, he's jumping around. So he's just jumping around all over the place. So he may move for a long time until he hits an edge. And then that's pretty much where a lot of them end up stopping, because they can only go east. They'll stop at east eventually. But this guy, he wants to keep moving around, so he'll randomly just kind of bop around all over the place. But yep. So that's kind of the shell of it. You can kind of see how it can make a game. You can kind of see how, like, with the way that we do pixels and the way that you do bitmaps, that it can kind of, you know, show you a pretty neat little history. You can, you know, make a world where, you know, there can be all kinds of things going on. Hope it helped. I don't know. It's been a fun project for me. I'll probably keep messing with it just because I want to figure out all of the formulas that he had going. So that's the next step for me, is to figure out how to add the math behind all of his behaviors. And that'll be probably a while. But once I get that figured out, I'll post it and see if it matches up. But, you know, it's something for you guys to make, maybe. Hope you enjoyed it. You know, it's not, I should probably just, you know, this is a quick throw it together just to make it work kind of thing. So there's a lot of stuff here, like comments are kind of lacking. There's more try catches I should be using. There's more variables I should be defining in the very beginning. But sometimes when you're going on projects like this, you just want it to get going, and next thing you know, you're working on the next class and you forgot to go back, you know. So there's little parts here and there. It's not perfect by any means, but that's the beautiful thing about programming is, you know, there's so many different ways to get to the one solution that it can be full of errors or all kinds of weird things that other people would see as, oh my God, that's horrible programming. But if it works, that's the bottom line. You know, if it works and it's not breaking all the time, you know, it's not every time you hit the button, it's not saying, wait a minute, we're running out of memory or something, you know. So, but there it is. I appreciate it. I hope everybody enjoyed it, and I'll put it on YouTube just for people to kind of play around with. Maybe I'll throw this stuff up on my GitHub and throw a link on the YouTube if I do that too, just for something to, in case people are, because I know that like making my other application for my game, there's a lot of things like this that I've run across to where there's no solutions on the internet for things like how to make a map or how to put an overlay or, you know, how to change a pixel sometimes is just confusing as hell to try to figure out. But if it helps anybody, then that's great. And I'll put it up there. Otherwise, have a good day. Thank you.